in the installer mode, okay, to discourage unauthorized change in the settings. In order to enter the mode, you gotta do what I call the bowling ball handshake. Okay, so what you do is you're gonna use 3 fingers like this and push that, and that gets you into the control. The controls already come default, but say maybe the 180 wasn't enough, maybe the boiler's a little on the smaller side, and we wanna raise up the temperature of the boiler, we can set the set point. So set point, see set point right here is default for 180. We can bring that all the way up to 220 degrees if we needed to. Perhaps we probably won't.
What happens if you go over 220?
That's
You
what
got
the
steam.
limit for the boiler's gonna be.
Yeah.
So you can go.
We can't go beyond that, though. I mean, you know, that would be ridiculous and dangerous. Of course, we can't let you do things that are dangerous, right? So simultaneously for 3 seconds until set point appears. Because the guys will say, you know, now look at this damn controller. Where in the hell from the old Aquastat world that we came from, how do I change the boiler water temperature on this damn boiler?
Right.
I don't know, neither do I. Holy Christ, what do we do? So you gotta use the bowling ball handshake, press these 3 buttons at the same time. For 3 seconds, SP is going to appear. Now SP, then we can get back to like what we did with the dial, right? We could change the set point from 180 up to 200 if we wanted to. Because a lot of times, you know, it's not necessarily, you know, the 180 wasn't working, or then maybe even necessarily the capacity of the boiler would be the issue. It could be what the connected load is. They got these freaking, maybe a higher output baseboard, and they really didn't put, you know, enough linear length in the baseboard, and the 180 ain't keeping up. So we gotta raise the damn water temperature up to like 200 because the connected load's maybe a little small, right? So we wanna make that water a little hotter, and this is how we get there. We gotta see SP appear, and you do that by pressing these 3 buttons at the same time till SP appears. SP gonna be set point. Next would be the differential, set point differential. 15 degrees is about where we wanna be. But you can go down as low as 10 or up as high as 30. We'll go with the default. Default is by and large fine. The biggest one that you wanna mess with here is the limit for the water temperature. And that's the first one you run into. So having done that, no problem. And of course, if you live in Canada and you want to change the thing to Celsius, you can do that in this menu too. We don't give a shit about that here. Right? Press up and down until the parameter has reached the desired value. After 60 seconds, without anybody touching anything, it's going to go back into the normal mode. So if you're saying, you know, having to push the button and we're talking, what do you think we should set this for? Well, I don't know. Let's take a look over here. Oh, well, now it isn't in there anymore. We got to do it again. Right? Okay, so that's how we get and make changes to the control itself. Okay, so now the boiler is going to display, as it operates, the display sequence for the high limit. So see, it says set point, and then it's saying 180, 180, and then it's saying degrees Fahrenheit. So then we're all good. In degrees Fahrenheit, we're going to press the I button to toggle the unit to measure what change we want to set for. This is how we change it. We change it by the I button here. So I button here, we're going to push the button, and we're going to raise the temperature on up if we choose to raise the temperature on up, and then it'll save and set its new temperature. These are the installer mode options. We've got the high limit differential. Another one, the pump overrun time is set default for 60 seconds. Who gives a shit? Why is that important? Well, you damn sure give a shit if you're doing it with zone valves. Because you don't want the circulator deadheading to close zone valves, do we? No, we don't want that. So in that instance, we would go and set that down to 0. Set that down to 0. So after the boiler made temperature look to shut off, we're not having the circulator continue to run deadheading to a dead closed zone valve. So that's another configurable set point, the pump overrun time, And that's gonna be the third one down, OR, pump over on time. Default 60 seconds. You got a primary, secondary loop, have at it, no problem. You want it that way, it's good. No
Did you
problem.
guys get that, what he's saying about why you want the circulator pump to stop? Because if the zone valve closes and the pump's running, it's trying to push water.
Deadhead.
Yeah, it's gonna.
You guys
burn the
got
pump,
that, right?
Yeah, gonna burn the pump.
That's, well, the default's to
Yeah,
run it for
because
60
You cannot
seconds.
circulate the water, you're gonna block.
Is
the
it
water.
gonna kill the thing in 60
Yeah.
seconds? Probably not, but you know, we don't need to be, you know, traumatizing the zone valves like that.
Yeah.
Hammering these
They're
zone
gonna be
valves.
both
closed.
under pressure.
So, we don't need to be doing that to them. So, that's pretty much what we're talking about here. You know, as far as usable and configurable options. Again, this is the 2112 compliant control, so we'll talk about the other one. This is what I was talking about, OR. Pump overrun continues to run for a default 60 seconds. Might not be the best pick for zone valve application, as I said, for obvious reasons. We could set that to 0 in that case, right? This control, remember those 3 wires that had the X over? On the Honey 112 control? This is for this device. If you wanted to get this and utilize outdoor reset, you know what outdoor reset's used for, what it's about?
What?
Let me tell you about that. Outdoor reset. Outdoor reset's like an energy feature. So today in the afternoon, where it's gonna be 75, 80 degrees, we don't need this boiler maintained at 180 down there all day long. So outdoor reset is gonna take consideration of the warm temperatures outside and shut the boiler off based on the outdoor temperature. It's gonna reset the values of the device inside. So with the maximum out temperature 42, 75 maximum temperature, we can tailor the minimums and maximums by basis of outdoor temperature. Hey there, puppy, you wanna learn about boilers there? Maybe not. I wouldn't if I didn't have to. Okay, so status, display sequence for boiler temperature status. It's gonna give you BT, but it's gonna stand for what the hell? Bacon, lettuce, and tomato?
BT's right there.
Yeah, boiler temperature, that's what I'm looking for.
It's right there.
Okay, sure, well, yeah, exactly. It says bold underneath it, this is making sure that you're paying attention to what I'm saying. Right? So, it's gonna say, now this thing is, you know, been off, it's down to 70 degrees, so nothing's happening. And then it's in degrees in Fahrenheit, right? This is gonna say the current status of the boiler. It's gonna display this all the time. So we're gonna know what the status of the boiler, without even looking at the other way. What's the other way we identify the boiler temperature of the boiler?
From the
Other
other
than
side.
idiot lights.
Little round.
Tridicator. Tridicator's gonna give you the pressure and temperature of the boiler up there, right? Yeah, still got those. Okay.
Now, these boilers, do they still have those? No, right? Because you have this.
These are dash twos. These are dash twos. So dash 3, we'll talk about dash 3 controls, so, but it's good to know.
Yeah.
It's good to know, because there's a shitload of it on the street. And these are all the different operational status codes that could take place. As in our chart, these are in the installation instructions that come with the boiler. If it shows code number 1, we don't gotta be getting too excited about that one, because that tells me it's idle, in standby, no call for heat. No call for heat. 4 would be pre-purged. When it's looking to light the pilot, it would show code number 6. So this is gonna call out, you know, we don't have enough space in there to say circulator's running. You know, we're not gonna, so you give me numerical code, reference to the numerical code, what the thing is doing. What the thing is doing, all right? So,
Actually, it displays a number when it's going through that sequence.
Right.
right,
And that board is on, it's on one of the covers.
yeah, it's right on the side, it's about this big.
Yeah.
It's like-
It's on the cover. So, and you see the numbers in the sequence. So
Right.
if there's an error, you can narrow it down.
Well, plus it'll give you full codes too.
Right.
Full codes too. So operational status code number 10. Retry, recycle, delay. So this one is now maybe one that we're hoping to run into a lot. The control failed to detect flame after spark period. Okay, so this thing didn't prove flame first time, and it went to sleep for a little while because we got to dissipate any kind of gas that was taking place in there, let that float away, go up the chimney and stuff, so we can safely try again. So in this case, we're gonna check the pilot and the flame sensor for any kind of contamination. We'll check the wiring and the grounds. Verify the flame signal. When the pilot is lit, we can tell what flame signal. Used to be, and again, when we had the old aquastat control, the only way to look at flame rectification was to use an external gauge in series with the flame sensor and measure the microamp signal. Most meters that you get, your field piece meter probably don't have the capability to measure microamps on its own. So migrate it over, we can now press the I button on the control, and it'll display the microamp signal that we're seeing from the flame circuit, right? So the flame circuit is gonna be at least over 0.23 microamps. That's the threshold where this control's gonna lock out. So it's gonna be 2.3 microamps or greater, or that flame is not gonna stay stabilized because the control's thinking it's dumping gas and the damn thing ain't lit, which wouldn't be good at all. So on this one, it's a little bit of a different arrangement, okay? So, you're gonna see, this sensor here is the sparker that's gonna spark against the flame hood and light the pilot, right? In between this pickle fork and this other sensor is where the flame circuit. So if some reason this thing got bent out of the way and it's not even in contact, well, obviously that would probably be where the area I would look, and I would bend that and get it into the right area so it was centered and making the right, right connection for the flame sensor itself, right? So here's kind of what we're looking, what it would look like live. See, the flame is making contact with the flame sensor and the hood, that pickle fork type thing. Now on furnaces and direct ignition controls, where you got the flame sensor right ahead of what we call in-shot burn, because these burners are gonna light the crossovers and then the flames come up, it's old school stuff for sure, right? But there's no way to make an in-shot burner and fire a cast iron block, right? The flame's gotta come up and go through the whole cast iron block. The furnace's clamshell design, we can have with an inducer drag that flame right into the burner. So a lot of guys get tripped up with flame sensors, and through the best of intentions, they try and get themselves out of problems, and maybe look to clean the flame sensor. What type of the tools do you use to clean a flame sensor?
I can use sandpaper.
Don't ever use sandpaper. We don't want to do that shit, because I'll tell you what. Sandpaper is way too abrasive.
Yeah.
It's gonna make scratches in the flame sensor itself. Those scratches give more purchase for more contaminants to come into the flame sensor. Also, sandpaper is made of silica. Silica is gonna leave behind an invisible trace of silica sand. In the presence of the flame, it's like clear coating the damn thing. So instantly the flame signal goes up, but it degrades rapidly because of the scratches that were put in the flame sensor and also the silica that stays behind. So you wanna learn about flame sensors? No, okay. So, the best weapon of choice is steel wool. Nobody wants to carry steel wool, because steel wool turns to a bag of rust like quick, that's not the best pick. So, Scotch Brite pad, okay, you can even raid the cabinet underneath the sink. The little yellow sponges, they got that
the green one, yeah.
that green scrubby sponge that Mom uses to clean the pots to make sure we're not eating crap and gonna die from it. So that is a really nice device. I use like the auto body shop. They got the thin pads. I cut them up. I used to hand them out, but it started getting expensive. I bought them, so I couldn't do that anymore. So those are a real nice choice. The little Scotch Brite pad. If nobody has a body shop or something like that does work like that, give me the Scotch Brite pad. The thing will last you forever. That's a better pick. even a dollar bill to polish that thing up would be better than nothing. Nothing. At least you have a dollar with you, I hope. Right. Made at least $1 the day before. So you would have that. So
Yeah, I saw that cleaning sensor with the dollar bill.
that's another way of doing it. But you don't, the bottom line is what the hell I'm telling you, you don't wanna use sand, because it's not the best idea. No more picking on anything.
I just said that so they can
I'm
hear
just saying.
your,
I'm
your
just
reason why.
That's why the hell you don't do it. But here the thing is, now you know that you should know, or you'll know today, the flame sensor is a switch, right? Yes?
Yeah.
It's only one side of the switch. The
Right.
flame is the switch itself. So the flame is gonna, as that flame hits the flame sensor, it's making the contact. In this instance, it's making the contact between the flame sensor and the pickle fork thing, because this thing's got a crossover. Now, on an in-shot burner, the other side of the contact is gonna be the burner itself. Okay, so if we had a furnace and we had problems with it throwing codes at us, that the microamp signal was too low, cleaning the flame sensor, putting a new flame sensor is only half the shot. So if you're looking at the end of the burner, and the burner's all like oxidized and that chalky white ash shit, you gotta clean that too. You clean that too. So by cleaning the leading edge of an in-shot burner and the new flame sensor, or even a clean flame sensor, you probably have it by the ash again. But just putting the new flame sensor in front of the dirty burner again, it may be.
Or you could change the whole thing out.
It may be, you know, in range, but it might be out. But this stuff you can do when you're sitting in front of it with no parts whatsoever.
Right.
You can fix this thing. You can right the ship. You can make sure this thing is going to have heat, and you can get the hell out of there, and everybody have a good day. They're not going to have heat. You're going to get your money. Everybody happy, and then you write it up that maybe we want to do, pre-season maintenance that you haven't done on this damn thing since 5 years. I put it anyway. You might want to talk about doing a maintenance contract on this stuff. So we don't have meetings like this, and I don't have to give you bills up their hours like we're doing here tonight.
Right.
So this is, kind of thinking that way. So this is what I'm talking about. Making sure that the microamp signal is within range and good, and what to do if it's not. Not only with this, but with any kind of device that uses flame sensor technology, which everyone does, right? So, the other one, waiting for the limit to close, indicates the blocked vent switch, rollout switch is open. Okay, this is a manual reset. Here's some other troubleshooting codes. I'll show you where the hell they are, because this thing here, and that's nice. But this is a resettable switch. You were talking before about the limits. Would we have any limits? Obviously,
That's the point. That's the switch that goes
That's
near
what
the
the
duct
hell-
vent.
Yeah, I know.
Sometimes they're in a square box.
There's
There
a
are
couple-
difference, yeah.
there's a
But
couple.
as we said from the other day, it was the same inside.
Yeah, exactly.
It's just like a color.
Yeah.
Now, if that sucker trips off, by and large, it did it for a damn good reason. So we gotta find out, did some birds make a nest in the chimney? Is the vent blocked? Did they put a steel door? We have lack of combustion here. There's a pretty good reason why we don't have a good path for.
So lack of makeup there can cause that.
Insufficient combustion here.
Yeah.
Boiler overfired. So then if it was like an LP job, maybe we had the schmuck that went there and count the turns of the screwdriver, which I told you not to do that at the very beginning. We don't work like that. So you would want to look at bare minimum. We're going to make sure that none of the venting is blocked or disturbed. We've got a good vent. If I see a couple of people smoking, you really can't do that in people's house anymore. They freak the hell out. So even if you take like a piece of paper, light it, blow it out, and you can look at the smoke, and it should be going up the chimney. Those are Rube Goldberg ways to establish draft without a draft gauge. But I like to, I like to give you a way to validate this stuff with the tools that anybody would be able to have. Right, so you can even just blow out a piece of paper and watch that thing, make sure the smoke is going up the chimney. It isn't blowing down, drafting down on you. Right. That the draft hood on the chimney, the little topper has been blown off in a storm or something. You gotta look around and not just hit the reset and split. Okay, so let's carry the thing out and look for root cause always. So we look the thing over good, and then we would take and look at the manifold gas pressure. Look at the manifold gas pressure, fire the thing up, make sure that you don't feel the heat rolling out of the draft in diverter, and also it's going the right place. Okay, so here's another one. Flame circuit currently too low. A non-critical alarm controls detected less flame current than it normally sees. There's still enough signal for the control to permit boiler operation. The flame circuit rectification needs to be checked. Check the equipment for a good ground. Ground on a boiler is not as bad as ground on a furnace, because it's piped, for Christ's sakes. Having a bad ground on a boiler, you really don't see that too much, because you got the thing piped. You know, there's shitloads of copper connected to that damn thing. So by and large, you're going to have a decent ground, but we should have a good ground. Coming in from L1 neutral and the ground. If it's wired in BX, we want to make sure some schmuck didn't take the BX wire and hook it up to a plastic box, because then there's no ground path anymore.
Right.
So we want to make sure that's going. Clean the flame rod like we talked before, and check the connectors to the integrated boiler control or plugged in properly, and the Molex pins didn't back out of one of the pins or something like that, right? So, sensor error, temperature sensor in the well not reading correctly, so it's not knowing what the hell the temperature of the boiler is. How the hell can I have the boiler firing when I don't know what damn temperature it is? It's not gonna like that. So if the sensor's out of range, we're gonna use an ohm chart. We're gonna pin that plug there and look at the ohm value of the sensor itself. And we'll know about by temperature what the ohm value would be. Whenever you're dealing with Molex plugs, gentlemen, and I mean this as a very good tip from your old Uncle Eddie here, and what we don't ever want you to do, don't take a Molex plug and pin it into this side of the plug with your meter leads. The safest way to deal with Molex plugs is on the wire end. Because if you put the meter lead in there and that pin connector is very small, you'll oblong the connector. Now you make a connection that's suspect.
Mm-hmm.
So by putting it in the meter leads, on the wire leads, there's enough room in there that you can get in there and measure voltages, resistances.
So you're going in from the other side.
The wiring,
Right.
going to wiring. We made years ago, we changed the Honeywell newer gas valves, the two plug ones.
Right.
And the pins in them things are about the size of sewing needles, really small, right? So people would take and look to see if they got 24 volts. They take the plug out and they stick the meter leads in there. Now they plug that thing in there, and now they need a wiring harness because they got the thing.
Yeah, they
Fix
expand
it.
it.
Trying to pull the barrels out of Molex plugs without the tools to do that, and getting in there with needle nose pliers to fix that after the fact, you're making a problem for yourself. So it's very easily avertable by going on the wire end. All right, makes good sense. Right? I actually talk like I've done some of this work in the past, not read the book, right?
Looks like.
It's true. So here is going to be the ohm range for the sensors. These are in the installation instructions, and we can look at, what temperature it is by the sensor, and then we can look at the resistance that we should see, and then we'll know that that sensor is good, because it's just a thermostat. That's all that is, and that's all it knows. If it's way out of range, it could be thinking the boiler is only 140 and the damn thing's 180 and the damn thing's getting way too hot, or all that switches are spinning up because the thing is hotter than it needs to be.
Mhm.
So that could be one of the reasons why we're resetting those controls, because we got a bad sensor that's out of range. Yes. All right. So now on the atmospheric damper, here's another one that could possibly happen. We got an end switch that failed to close. We verified a damper operation in the first place. We don't have somebody put a zip screw down too low and, bound the damper mechanically. The damper's freely to move mechanically, and that could be why it didn't make the end switch. Or somebody egged this thing out, so it's pinching the damper, so we'll make sure it transitions smoothly. Okay, with low voltage error, we're gonna wait for, we measure our low voltage from a transformer and the boiler, make sure it's at no less than 18 volts, but really not much higher than 30 volts. And that's gonna be dictated by the primary voltage, of course. When we see low voltage readings on transformers, generally they're in association with low voltage from the power supply to the boiler. And generally, the best recipe for something like that is the red switch upstairs, that kind of, you put it down and
Yeah.
it doesn't float down, and all of a sudden it snaps down, it's kind of binding, it's real sticky and shit. And then we look at the board's not happy, it's only seeing like 16.5 volts for our low voltage circuit. Circulator's running slow and all kinds of stuff is happening. We look at, and all of a sudden we're seeing voltage down like 98 volts. And then we look, at the panel, we know everything else. So, we check an outlet on the wall, for Christ's sakes, we're seeing 120, 130. And then it's gonna tell you that perhaps that interlock switch on the stairs that's been there since the 40s might be in need of replacement. And this one here, soft lockout, refers to, this one is the number of tries. This thing, tried multiple times, and then it finally went into this lockout code, because the maximum number of tries is 5 times for this thing to try and light. And it isn't proven flame for 5 times. So that's gonna be fairly obvious to see, because you see that the pilot does, it tries to light, the pilot comes on, it doesn't stay lit. And then we're gonna have to do like the steps we were talking about before. But we share a numerical code, but this happened 5 damn times and now it's in a soft lockout.
How long is this soft lockout time for?
Soft lockout, failure on the board, self-diagnosis, it detects the error. We're gonna inspect the pilot light. That's gonna probably, it's gonna stay like that. If somebody were to drop the power out, it'll try another 5 times, but there's a problem that needs to be identified, because it can't sustain the pilot. We can't sustain the pilot, we're not gonna be able to, maintain that boiler. So, if everything else checks out, and we see the microamp signal, the pilot and everything all checks out, the Molex plugs and everything are transitioning to the board properly, they're loose, they're not back pinning or nothing like that, and we see a higher value than 0.23 being displayed, it's still locking out, we got no other choice than to replace the board at that point. The board is just,
Yeah.
it don't wanna work today. So, we send it home in the box that came with the new control.